Today we're going to talk about how you can use the average value integral in contextual problems. Here's our first example. The cost, C of x in dollars, to build a tunnel is a function of x, the length of the tunnel in meters. Interpret the meaning of this definite integral expression in the context of this problem. I recognize that this definite integral has the same form as the average value integral. And so I know it represents the average cost in dollars to build a tunnel from x equals 0 meters to x equals 500 meters. Here's our second example. The number of people at the state fair, P of t, is a function of t, the number of hours since the gates were opened. Interpret the meaning of this definite integral expression in the context of this problem. Notice again, this is a slightly different form of the average value integral. This time, notice that our integrand includes a derivative. So I'm finding the average rate of change of P of t in people per hour. Notice that those are rate units from t equals 2 hours to t equals 5 hours. A follow-up question says, to write a definite integral to determine the average number of people at the state fair between 3 and 8 hours after the gates were opened. So, I know to find an average value, I need to use an integral expression in this format. For this particular problem, I'll have 1 over 8 minus 3, integral from 3 to 8, P of t, because I'm looking for the average number of people, dt. I could obviously simplify this and write my answer like that. Here comes our next example. The rate that water enters a tank is given by R of t, where R is measured in gallons per hour and t is measured in hours. Determine the average rate that water enters the tank between t equals 7 and t equals 10 hours. Again, I'm asked to find an average. I'm looking for the average rate. Well, R of t is already a rate, so I'm going to be doing 1 over 10 minus 7 integral from 7 to 10 R of t dt. Of course, I can simplify that. Here comes our next example. The rate at which a virus spreads through a population is given by z of t, where z is measured in people per day, and t is measured in days since the first infection was discovered. Interpret the meaning of this definite integral expression in the context of this problem. Again, I recognize that this is of the form 1 over b minus a, integral from a to b, f of x dx. Notice that the 4 is 6 minus 2. This represents the average of z of t, which is the rate at which a virus spreads through a population, and people per day, from t equals 2 days 2, t equals 6 days. Here's a follow-up question. It says to write a definite integral expression that will determine the average rate of increase in the rate the virus spreads through the 4th and 7th day since the first infection was discovered. So, I'm looking for the average rate of increase in the rate. So to find an average, I know I should be using my average value integral, and it says between the 4th and 7th day. So, integral from 4 to 7. And because I want to do the rate, I need to take the derivative. So I'll have z prime of t dt. Thanks for listening. Enjoy calculus.